Okay, you can see the slide, kan? Okay, so kan takut the wifi tidak kuat di sini. Bolehlah kan? It's okay. Okay. So today we will look into neural network. A neural network is one of the machine learning that can be used to perform regression and also classification. These two main category in machine learning. So regression and also classification. So today we will look into what is neural network and how it works behind the scene. So the artificial neural network was established long time ago, in which they plan to make human intelligence by looking at how do we get the input from our sensor, from our eyes and everything, and then how our brain process the input, and then in return of that they will perform some action. So over here we have all the input from our so the input, and then our brain process all the input that we get from our vision, from our finger, from what we think, and then they will produce the action here. Okay, so AI cannot imitate human intelligence completely, but some part of the human intelligence can be illustrated by performing some function that is already programmed. Okay, like for example, they're looking at how do you cluster, or how do you perform classification, or how do you forecast the trend, and also how do you recognize the object. Okay, how do you classify the object? So all of these things are some of the motivation that driven the research in neural network. So now, last time we only have neural network. Now they go into deep neural network, and then they call it now deep learning, in which we have more complicated topology of neural network. Okay, so like I mentioned just now, deep learning is one of the method that use as machine learning, and we know that in the first chapter we look into machine learning when we want to perform data mining, and data mining is one of the pillar in AI, because AI study about the systematic study of how our function, our brain functioning, then how do we process the input in order to produce some of the output that we have. And if you look at the previous diagram, this is just a single layer, but we could have multiple layer of input, no, of hidden layer. Then we could have multiple input and also multiple output depending on the task that you want to do. And deep learning is mostly well known with the task of image recognition, image classification, and handwriting identification. So when we talk about deep learning, it's basically a set of neural network with more layers, more hidden layer here. And in the next chapter, we will discuss about perceptron. Perceptron is one of the variants of neural network in which they only use a single layer of neuron here. So we don't have all of these, but we only have one neuron, or one single layer of neurons. So when we try to compare human brain and also the competition of neural network, is how they make the analogy. So the dendrites is part of the brain who will get the input. So we get in the computation of neural network, we have all the input. Okay, in the brain we have dendrites that act as input receiver. So we also have this axon. So this one is just a connection between the processing item here that will trigger to the next neuron. So when we have this input here, so we have the input. So basically, when we compute the threshold here above certain value, it will fire or trigger the fire to process or send the signal to the next next neuron. And we also have this nucleus. This nucleus is basically a cluster of neuron in the central nervous system. So this is our nucleus here. So this is our dendrites. This is the input that we get. So this is the cable that will send the signal from this input to the output. So this become the input to another part of your brain. So that's how we make an analogy between our brain, part of our brain, and also the neural network. So before we can fire some value here to the output here, of course we have the input from the multiple input that we have. So this is our input. Okay, so we have one hidden layer here. One hidden layer. So the fire will be triggered here if the computation of this threshold is over a certain value that we have predefined before. So we will look into this, how they compute and what function they use, what activation function that they use. Okay. So basically we have this, but what we need to do is we have to know that we have the input layer, we have the output layer, and also we have the hidden layer. And at the same time also we have to look at the weight of the individual item that we have, because when we learn or when we train the neural network, basically we learn the weightage that we can adjust to trigger the fire. Bias is just a computation that will somehow change positive to negative in order to match the actual output of your data. And the activation function is used to compute whether you can trigger the fire, fire the trigger to send the output. Okay, so we look into more that one. So in this diagram, we have three input. So we have three input and we have one output. So normally when we try to learn the data, we have the three feature or more than three feature, and also this is the label, the class membership. So in order for us to train the machine, we have to estimate the weightage here, so that whatever weightage we set for this W1, W2, and W3, it will map all the input that we get to the right classes here, to the right label for the training data that we have. Okay, so for this calculation, so basically this is the summation of all the dot product of the weightage and the input. So we have the weightage and also the input, and the bias here is used to adjust the output so that it will increase the accuracy mapped to the actual label later on. So neural network bias can be defined as the constant which is added to the product of features and weight. It is used to offset the result. Offset the result means adjust so that it will map to the right label or it will map to the right process. it helps the model to shift the activation function towards the positive or negative side. So this is just to make sure that they are mapping to the right class, positive or negative class. Okay, so when we go one time here, this is one epoch. So during the training, they have to adjust this one so that it will reduce the cost of error. So they will run through many times. So when you use the neural network, normally you put 10,000 or 100,000 epoch. So it means that it will get W1, W2, and W3 that will reduce the cost of error here. So that is the process of learning. Okay, so basically in the process of learning, they modify the weight to better approximate the desired function so that this one will be bigger to produce the right to produce the output map to the correct label that we have. So when we talk about the activation function, we have this. This is the basic one. This is the linear function. It means that if your x value is positive, it will give you a positive output also. So if your x is negative, then it will give you the negative value also. We also have this. When your x is greater than 0, it will trigger 1. If your value is if your value is 0 or greater, it will trigger 1. If your x value is less than 0, it will maintain 0. Means you will not trigger any values that you want to fire to the next neuron. Okay. We also have this what we call the sigmoid. The sigmoid, when you look at here, the value of the x must be somewhere here. But when we talk about the x value here, it will a small change of x here will give you a high changes in y here. So that means we have to adjust slowly what is the value of your punya x so that we can get the right value here. So when we talk about gradient to vanish means some of the value that we have here, if we change x too much, you will not be able to find the good result. You will have high error. Okay? So it is slow convergence because you have to use very small x here in order for you to get the trigger higher. We also have this hyperbolic tangent, but the value for the y will be between 1 and -1. So this one gradient is stronger for this hyperbolic tangent, stronger because you have a steeper slope here. So your punya range value will be somewhere here and here. A small change here will have big impact here. So when they say the gradient is stronger here because you have longer value here that you can adjust from 1 to -1 compared to this. We only have one part only, which is the positive and 0. Positive 1 and 0 only. 1 and 0 only. Okay. The last one is rectified linear unit. So this is the most common activation function used because they produce good result. So what happens is that your value will be 0 if your x is less than 0, and your x will be 1. Oh no, your y, this is your y, will be whatever value you get for your x. Okay? So in this case, they said it does not have the vanishing gradient problem, meaning that you will be able to reduce the cost as a matter of time only. So you will not miss the miss the cut. I will show you later on what is the vanishing gradient problem. Let me fast forward first. Okay. So what happened here that if your initial weight is here, okay, so your aim is to get the less number of error. So once you reduce the weight or increase the weight here, so sometimes you increase too much. You will miss this low cost minimum, global cost minimum. Okay, so you will go up here. If you adjust the weight just very small, so you going to here very slow. So that is what we call the gradient descent approach, in which some of them have error because your when you adjust the weight is too much, so you will go over the global cost minimum. But if you change the initial weight too small, you will have will stop somewhere here because you're changing the initial weight too small. So sometimes they call it the learning rate. So if your learning rate is too small, then you tend to stop here at the time you have 10,000 epoch. But if your learning rate is high, then you will end up here. Okay, so what is the problem here? The objective of deriving gradient descent at each step is to find the global cost minimum. You want to go here. So adjusting the initial weight is very important. What is the learning rate and how much you want to change? So that is what we call the gradient descent. So if I go back here, so that's explain this one. This one say that this is good activation function based on what people have used. They say that you can go to the global cost minimum very effectively. So when you use the ReLU, most of the time you get better result. Okay. We'll study this one in the next session. So this is one of the variant of neural network in which you have multiple input here and you only have two type of output here and you only have one neuron. So basically if the y value is positive, call it positive label. If the y value is less than or equal to 0, it will be negative classes. So we will look into this one in the next lecture. Okay. So we know that we have the input layer, we have the hidden layer, and also we have the output that we want to trigger. But the activation function is they use this value in order to higher value to the next level. So if we go to one cycle here, this is what we call one epoch. So this is what we call the feed forward of information one way only. But if you feed the error back into the neuron, they call it the back propagation of error. So we also have back propagation neural network in which they feed back the error so that they can adjust the weight more effectively to get to the global cost minimum. So so this is the difference between the feed forward and feedback network. For the feed forward, they only go to the front to complete one epoch. But for the feedback network, we have one go here and then we go back here. So this is considered as one epoch also. But you need to send back the response back to the uh, previous neuron so that they can have some knowledge how much to change the weightage that we have. Okay, and the latest one, this is for the recurrent neural network, mostly used for sentiment analysis or classification of text or forecasting the time series. Okay, so what happened is that for the recurrent neural network, they send the output back to the previous layer. Okay, so this is just to look into what how much error that you need to cover in order to change the weightage for all your input that you have. If you don't feed them back into the loop, or they just call it forward neural network. So when I talk about the learning rate is how much you change um, the initial weight in order to best global cost minimum. So over here, the good learning rate means that every time you adjust the weight, you always reduce the error. The, the epoch number increases. Okay, so this is good learning rate. Okay, high learning rate means that you reduce the error, but your improvement is not increasing. So this is high learning rate. You reduce so fast, but at one time your loss will be stable. Okay, so the low learning rate, we compare the blue and the green. For the same epoch, this one will have lower cost compared to here. So that's why this is low learning rate compared to the high learning rate. We also have the very high learning rate in which you change the weight too much that it reduce the error, but suddenly you increase the cost as you increase the number of epoch. So what we want to have is you want to have good learning rate. That's why when you try to run for the neural network, you have to try few number or few values of your learning rate in order to get the best result. Okay, so in short, deep learning is a complex set of neural network and can be used for building application based on AI. So it can be used in various applications such as image recognition, computer vision. This is for the object identification or object detection. We also can use for handwriting detection, or we could use text classification application, multi-class classification, and regression problem. But the bad thing about this neural network is that when we train the model, they will adjust the weightage. And then when we try to classify a new item, there is no explanation why that new item is classified as positive or negative class, because they are in a black box. So the pro for the neural network is that you can do both regression and also classification. Network are good to model a non-linear data in which you cannot draw a line to separate positive and negative. Okay, so you can use other application like the support vector machine, but for neural network, this is good when you have your data and you cannot use linear type of machine learning to divide them. Okay, so neural network is good when you have non-linear data. Okay, once trained, the prediction are pretty fast. and you need more number of input, more training input, but that one will become the disadvantage also, because if you do not have enough sample to train, then your model will not be so accurate. So and also and this is what I mentioned just now, black box. We do not have the explanation why a new item is classified as positive or negative, because the weightage of your neuron, or the weightage of your input, are learned by adjusting the weightage so that it will map to the right label. And one of the disadvantages is that you need a lot of training data. And this is some of the good practice. They say that neural network are best implemented when you have good number of training data. And they say that you have, if you use the multiple layer perceptron, you get better accuracy. Okay, and they said for each of the hidden layer, 5 nodes is enough, and we could use the ReLU as the activation function to get a better result. So let's look at a simple one. So this is simple application. So given the input that we have here, we need to get the output similar to this. Okay. So based on our thinking, we look at the input and we look at the output. We know that the output can be produced by having square of the input get the output. Like for this one, we need to have the square of this value, or similar to other input value. Okay? So how do we train the machine, the neural network? Is that we just provide them the input and the output. They will estimate the weightage for each of the input, can map to the output that you have. Okay. So this is a step by step how you can use the R software. So the first thing that you need to do is you need to install the package neural net, and then you upload into the memory, and then after that we read the square.csv. So this is the file that consists of the input and also the output here. So this is your data. Okay. So this statement will attach the database to the R search path. So when you get this data here, so they know that where to get the data that you put here. And then we also know that this is your Y, this is your X, this is your Y. So you need to model this Y based on the X. So this is the tilde that you have. So this is the tilde. So this is your output, tilde, and then this is X. This is your formula. And they say that, okay, why not I use 10 hidden neuron. The threshold to trigger the fire is 0.18. Okay? So based on this statement, we model our neural network based on one input and one output, because we say the output is modeled based on the input here. Okay? And then we have n neuron here. So all of this weightage will be estimated by model by itself. So when we plot, we get this. Okay. Now what we want to do is, because we have this model, so we will call this model here. As the model here consists of the result that we send them. Now, we want to compare this result with the output that we have. So basically, this one is just combining the column input, output, and also the result, and this is just renaming the column name. So we have the input, we have the expected output, and also the neural output. So we just compare. So what we can do here is that we can count the differences between the expected output and also the neural net output here. But taking the differences and then take the square, then you add up all the differences here. So this is just a simple example. Okay, we could also do something like this, in which we try to build a neural network with the purpose of predicting the fuel consumption. So this is the miles per gallon, which is the fuel consumption. And we will look into the cylinder, displacement, horsepower, and then weight and also acceleration. We don't need this because that has nothing to do with the miles per gallon. Okay? So your y will be miles per gallon, and the rest will be x. So how do we model the miles per gallon based on all the 5 inputs that we have? So we get the neural network here. So this is the data that we get for the auto here, and then this is our data. So this is the y, the output, and this is all the x's. So this is your x. So this is your data. You have the miles per gallon to learn. It's on your 5 columns, which is the cylinder, displacement, horsepower, weight, and acceleration. Okay, and this is just to plot the weight against the miles per gallon. And we also could plot them based on other like the cylinder and then displacement and also the acceleration and also horsepower. So we can see that some pattern here like displacement, acceleration, and horsepower, they have some kind of relationship with the miles per gallon that we have here. Okay. So the next thing that we want to do is, if I go back to the input that we have here, some of the value are when we compare column by column. Like for this one cylinder 8, this is 307, and this is 12. We do not want to have one column that dominate the other column. So what we need to do is we need to normalize our data. So how do we normalize? We use the min max value. Now in this case we use the mean and the standard deviation. So this is how we normalize them. We get the mean of that particular column and also the standard deviation of that particular column. And then for every value in that particular column, we will perform the scaling like this. So like this one will find all the mean for each column. This is used to find all the standard deviation for each column. And then I will apply the this formula, this scale using the mean and also the standard deviation in order to normalize them. So when I try to print out the values for each of the column, so you can see that the value is the differences are not too much. So cylinder displacement, they are around 1 point something. Compared to the previous one, we have big differences here between the weight and also the cylinder. So the normalization of the data is used to avoid specific column to be more more bias in terms of trying to get the right weightage for each of the column that we have. Okay, next one is once we normalize them, we have to divide them into training and testing. So training is 70%, testing is 30%. So what happened here is I will use the sampling method around 70% to get the raw ID. So once I get all the raw ID here, but only 70%, I will select them and I will put them in the training dataset, and the remaining I will put in the test dataset. Okay. So once we divide them into two, training and testing, now we want to set the formula. The formula that we want to set is this one. Because we have the mass per gallon as the column that we want to predict based on cylinder, displacement, horsepower, weight, and acceleration. So can just simply type F equal to, we type the whole thing here. So that when we call the neural network, we just put F here. So when we call the neural network, we have this formula, and then we have the training dataset, and we have 3 neurons in the single hidden layer. And the linear output, meaning that we are using number, because the final output that you have here is a number, a numerical value. So that's why we put linear.output equal to row here. So when we call this function, or we write this statement, basically we train the neural network all at here using this formula, using this data, and using this topology. So this is the topology of your neural network. So now we want to use this network, this model, to predict the 30% that we have, the test data set. Okay. So now we want to use this net, and then we want to compute using this test data that we have. Okay, so remember that the training data is used to train the model, and then we use the compute to perform the prediction based on the data that we have. So we put the result in here, and then this one will compute the differences between the actual mass per gallon and also the result that we get. So this is the actual mass per gallon that we have in the test data, and then this is the result that we get. And we the square just to remove the negative value, and we divide by number of row that we have. So this is mean square error. So the mean square error is 0.301. So if we use another model that you have learned before, or you have learned the linear model, okay, we are trying to model the mass per gallon based on all the variable that we have, and this is your data. Then when we use this model to predict the test data that we have, we get the result here. And then we compute the mean square error by looking at the output of your model minus the actual value for your test data, and you take this square and divide by number of tests. So this is the mean square error using linear model. This is the mean square error using neural network. So what it means here that the lower mean square error, the better is the model. So based on this result, we are saying that okay, our neural network is better compared to linear model because they produce less error. So when we plot them, they are more or less the same here. So these are the data versus the predicted one. So this is the actual mass per gallon. This is the predicted one. So this is just to look at visualize the data that we have. If we want to compare the test data and also the predicted value. So this is using the neural network. This is using the linear model. Okay, this is another example. Okay, so before I proceed, do you have any question?
Belum ada lagi, dokter.
Okay. Okay, this is the next one. What we have here is that we have a class we want to predict here. So we have all this value that we have. So this is a numerical value. So this is, we want to classify them. So this is what we get the data from the breast cancer. Then we summarize them. So basically what we have here, we want to classify this based on all this value that we have. So just imagine that we have Y value here, and this is all the X's that we have. And this one is, okay, before that we have this one, NA. So NS means that they are missing value. So what we can do is we can unlist or not listing all the value that has not applicable here. So basically we are applying the not listing here for all the value which is missing. So when we try to summarize them back, so now we do not have the not applicable anymore. Okay. So this is just to clean the missing data. If you look at the box plot, so this is basically tell you the average or the median that we have for each of the column that we have. So since they have different median, different mean, so basically we want to normalize them because we do not want to have some column has higher influence. Okay, so this is just to look into whether your value, they are plotting the histogram for all of the X value or the independent value that we have. So this is the plotting. Okay, so we also look at the data here. So what we want to do is we want to extract that number 2 until the number 10 here because the ID has nothing to do with the classification. So we just remove the first one. So that's why we have, we take all the row here and we take column number 2 up to 10. So we remove the first column. And we also look at the value that we have here because if you go here, all of these are the factor. So we want to convert them into numerical value. Okay, so in this one, we just simply we apply the function as numeric. So what happens is that we take the x, convert them into character, and convert them into numerical value, and put them in the data frame. So we have this one. So this is just to convert the character into numerical value because we want to have the actual numerical value that initially we have in the dataset, in the data frame. Okay, and since we have different median here, in this one box plot, value that do not have same median, mean. So we use the min max in order to scale them. So basically for each of the column, we find the minimum and also the maximum, and we take of each of the value minus the minimum and then divide by max minus min. So this is a standard scaling formula. So this is what we call the min max scaling. So once we scale them, we have this. So once we scale them, so next one is that we need to look into the classes that we have. So for example, if you look at the class that we have the benign malignant. We have two types. So what we want to do is we want to convert this one into two output. So one is cancer benign and one is cancer malignant. Okay, if they belong to the cancer malignant, we have to put one here. Otherwise, you put one. So basically what happened here is that we are converting the single column here into two column here. So this is one column to two columns. So this is because we want to perform classification. Classification in this task is two classes only. So this one will, so each column representing the class of output with its probability. So once we have this, then we can later on compare with the result that we have in the neural network. Okay, now we will combine the input scale and also the cancer that we have. The cancer that we have will have two here. So remember that in this slide, we are changing the one column here into two. So this one, we are combining the column for the normalized value that we have with the two column that we have for the cancer. So we will use this data and we feed into the neural network that we have. Okay. So before we feed them into the neural network, once again, we perform the 70% and 30% split of data. So one is used for training, 70%, and the other one is used for testing. And this is just to form the formula. Okay. So this is your y. This is your x here. So this is the formula that we'll be using. So when we call the model, so we use the formula that we have find previously. We use the training data set. We have the 5 neuron, and because we are not estimating numerical value, we are looking at the probability of having this and or this one. Okay, so that's why this is false. So when we get that topology drawn here, and then this is the model that we have trained. We use that model to compute for this test that we have. So only 1 to 9 because the 10th and the 11th are the cancer name. So once we get the result here, then we get the net result here. This is what we have. So this is the class benign. This is malignant. So we want to compare this with the actual one that we have before in the testing. So what happened here is that we are converting them back into the name that we have before. So this is, we are looking at the based on the predict result here. Okay, so if one, they will put the benign, so otherwise they put the malignant here. Okay. Okay, so when we construct the confusion matrix, this is used to look into the accuracy. So we have this, and the error that we want to point out is this one. So 9 over the total of all this. So the total is around, this is 1, 2, 9, and 76. So 5, 1. So this is 205. So the error is this one. And this is when we want to plot them using the cross table here. So they show you the error is here and here, and 9 over 205, which is this one. So I think later on we need to do some practical on this one. So we will meet in the lab and we will do all of this. Or maybe if you have time, you can go through step by step. So basically, the slide is designed making sure that all the steps can be done or can be completed without any error. So you can try lah. So basically, neural network can be used for supervised, which is the classification, or unsupervised, which is the regression. We look at the weight, the biases, and the activation function when we talk about training the neural network. And they are used for nonlinear function in which you cannot draw a line to solve the problem. They are very fast if you have good input. And also we have this forward and back propagation, so we will learn more on this. This is the basic neural network that you can have. All right, 1 hour, 6 to 7. So any question?